Okay, so today we're going to look at 12E, where we look at graphing not just one inequality, but we're graphing multiple inequalities with the idea that we want to find this feasible region. And the feasible region is the region that all these inequalities is satisfied by. So when we look at these first two inequalities, x is equal to or greater than 0, y is equal to or greater than 0, we know we're working in the first quadrant. And this will become more important as we look at problem solving and using this in actual situations for modeling. The first quadrant is all positive numbers. So we're looking at just the y-axis in the positive and just the x-axis in the positive. So we can already rule out any negative values because we're working in the first quadrant, which means we're looking at the intersection and the area that these two cover within this graph. So let's start off by what we've been doing every time is finding our x and y intercepts. So on one side of this table, we'll have our first equation. On the other side, we'll have our other equation. Now we can draw in our table of values, x and y. So we want when x is 0 and when y is 0. That will give us two coordinates. And again on the other side. Okay, so let's begin with our first equation. So, when x is equal to 0, so the first thing we're going to do is substitute 0 in for x. We have 2y being equal to 10. So we divide both sides by 2. And y is equal to 5. So we have our first coordinate. Fantastic. Next, when y is equal to 0, we know that x plus 2y is equal to 10, so we have x plus 2 times 0 is equal to 10. We can straight off the bat say that x is equal to 10, because 2 times 0 will cancel out. So we have x is equal to 10 for our x coordinate, or x-intercept. So now we've actually solved the intercepts for this first equation. Now if we look at our second equation, when x is equal to 0, we do exactly the same process. We have 6 times 0 plus 4y being equal to 36. We know that 6 times 0 cancels out. That's actually 0 plus 4y. There's no point writing it. 4y is equal to 36. We want y by itself, so we divide this by 4, which means we also divide 36 by 4. Y will be equal to 9. So we have our first y-intercept for this equation, and our only y-intercept, by the way. Now let's look at when y is equal to 0. And that will give us our x-intercept that we need. So when y is equal to 0, we have 6x still plus 4 times 0 being equal to 36. So we know that 6x is equal to 36 because 4 times 0 is nothing. That will cancel out. Now we're left with 6x is equal to 36. We want x by itself. We do not want it multiplied by 36, so we divide by 36 on both sides. X will then be equal to 6. And that gives us two sets of coordinates. So we can now use those two sets in order to make two different lines. So if we're looking at this first equation, which I'll be writing in red, we need to use our coordinates in order to plot this on our graph. So our first coordinate, 0, 5, we will start at 0, and we will go up 5 on the y-axis, 2, 3, 4, 5. And then we know that the x-intercept is 10, so we will go across 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right at the end. Now we know with these equations that they are equal to or greater than. Equal to or greater than. So every line that we draw will be a straight line. There'll be no dashes included. So we label this line x plus 2y is equal to 10. Now we also have enough information to fill in our other line to form this region. So we know that when x is 0, we have a y-intercept of 9, so we can count up to that. 5, 6, 7, 8, 9. Then we also know that we have an x-intercept of 6. 1, 2, 3, 4, 5, 6. So we can now draw in this line. And we can label this one, I'll see if I can write this on the side. Six x plus 4y is equal to 36. So we also need to do some test points, right? So we have now graphed the line of the equations. And now we need to also do some test points. And we'll use 0, 0 again. So for example, when x is equal to 0 and y is equal to 0, move this forward a little bit. When x is equal to 0 and y is equal to 0, we know that 0 plus 2 times 0, that's supposed to be greater than 10. So 0 is equal to or greater than 10. We know that's not true. So we know that the origin will not be included within that equation, within that region. Let's try the other equation. When x is equal to 0 and y is equal to 0, we have 6 times 0 plus 4 times 0 is greater or equal to 36. We know that that forms 0 equal to or greater than 36. We also know that's not true. So we know that for both of these lines, for both of these inequalities, the origin will not be a part of it. So you know this point will not be included. So if we were wondering if it was this side of the line or this side of the line for 6x plus 4y, or this side of the line and this side of the line for x plus 2y, we now know that this side of the line for 6x plus 4y is not correct. So we'll be shading this area. When we look at this line, we know that x plus 2y, it will not be this area. So we need to shade this area. So when we look at shading, this is what it will look like. We will shade the area that satisfies both of them. So it will be all of this area. But where the blue line meets the red, that is where the feasible region for the blue line ends. So we actually need to only shade where it satisfies both of those inequalities. So that will be all of this region here. So the next recording, we'll look at how do we actually figure out this point here, where the intersection is. Because this point becomes quite vital when we look at a minimum and a maximum value. So have a look at the next video, which will relate to this one, and we will look at using simultaneous equations in order to find that point between those two inequalities.